Many of you may have seen how to bisect an angle before. For the benefit of those who don't know, we'll do a brief overview of how the process works. I'll show you one way of bisecting an angle, and then we'll move on to exactly why this method works. For those of you who already know the process well and would just like to see the proof of why this method must work, feel free to go forward to the Why It Works chapter. The chapter is linked in the comment section and in the description. So let's see how we bisect an angle. Let's say we wanted to bisect the bottom right angle. The first thing you would do is place the point of a compass at the right hand side vertex of the triangle, and then draw a curve that intersects with each of the edges adjacent to the angle. Then from each point of intersect, highlighted in red, draw two curves that intersect. So starting with the intersect point on the right, place the point of the compass at the intersect and draw a curve like this, and then without altering the compass, place its point at the other intersect and draw another curve, and be sure that both of these new curves intersect. And the final step is to draw a line between the vertex of the angle you want to bisect and the intersect point of the two new curves. I'll highlight that. The line passes through these 2 points, and so the angle values either side of that new line will be identical. And that's how you bisect an angle. But our main purpose is to understand why this particular process results in a bisected angle. So we're going to repeat the process once again, but this time we're going to analyze each step and use the knowledge we have about curves, points of intersect, some basic properties of polygons and angles, so that by the end of the analysis you will understand exactly why the angle is bisected when we use this method. So let's begin. So we want to bisect the base angle on the right. We've highlighted that vertex, and we use a compass at that vertex to draw a curve that intersects with the edges that are adjacent to that angle. And here are the intersects. Now, because the origin of this curve is at the vertex, each point on the curve must be the exact same distance from the vertex, which means the distance from the intersect point on the right edge to the vertex must be exactly the same distance from the intersect at the base edge to the vertex. Let's say that the value of both lengths is x. And now we're going to draw the other two curves, each having its origin at one of the intersects. Let's draw the curve based on the right intersect. Now, since the origin of this new curve is the intersect at the right edge of the triangle, each point of the curve must be exactly the same distance from that intersect. And then we draw exactly the same size curve based on the intersect at the base. And each point on that curve must be exactly the same distance from the intersect at the base. But these two new curves are intersecting. Let's highlight that intersect. Now normally the next step would be to draw a straight line that passes through the vertex and this new intersect. But I'm not going to do that yet. I'm going to add in a couple of new lines. I'm going to draw a line from the intersect of the two curves to the intersect at the right edge of the triangle, and a line joining the intersect of the two curves to the intersect at the base edge. Now, if we think about this, the first line goes from the origin of the upper curve to the edge of that curve, and let's say the length of that is b, but the other line goes from the origin of the lower of the two curves and ends at the lower curve. And because these two curves are exactly the same size, the length of this other line must also be b. But because both lines meet at the intersect, both lines must be joined. And we've ended up with a new shape inside the triangle, and hopefully you can see it's a quadrilateral. And now if we draw the straight line that passes through the triangle vertex and the intersect of the two curves, we get another result. We've created two triangles out of the quadrilateral. And you should recognize that these triangles are identical because they both have an edge of length b, an edge of length x, and they share this edge, which is the diagonal of the quadrilateral. And since the triangles are identical, that must mean that for both triangles, the angle between the edge x and the yellow edge must be the same. Let's give those angles a label, and if we clear away those extra lines and their values, and these lengths and their labels of x, we can see that the structure we created did in fact bisect the angle. So now you know why this method works. Well, that's it for now. Thank you for watching.